Welcome everyone. In this video we will be taking a look at bubble sort, or the bubble sort algorithm, and we will be doing that by visualizing the algorithm as it is running. Previously we did linear search and binary search, and since then I've added this sort field or this sort slider, and all that does, say for example we are searching for 39, we can increase the sort speed by dragging it to the left and make it slower by dragging to the right. And yeah, as I'm saying this, I guess it makes more sense to increase the sort speed if you drag right and decrease the sort speed if you go left. But for whatever reason, when I did this, I made it go to the left, being faster, and right slower. I might change that in the future. But yeah, I just wanted to show you that. Same for binary search, you can increase the sort speed. And then now if we look at bubble sort, you will see that we have a sort button and the sort speed slider. And yeah, it will be better to just visualize this, and I'll explain it as it is going. So the first thing that it did, it just scrambled all of the nodes. And now what it's doing, it's looking at these nodes two at a time, seeing if the left-hand node is bigger than the right-hand node. And if it is, then it does a swap. So as you can see, 74 is quite big. So for each of these nodes, it's just swapping 74 to the right-hand side, essentially trying to get 74 to the farthest right side to get it to the value that will be the biggest, so the end node. And then it's basically just doing that for each and every node. So 74 is now placed as the end node, and now it will just continue to do that until it finds the second last node and then the third last node, and it will continue to do this until we get to the final end node and everything is sorted. So let's speed this up, and let's speed it up a bit more, and let's go crazy and just run through it. As you can see, but if you're following, it's quite crazy. And yeah, that's essentially it. I'm actually quite proud of this implementation. I made a pretty unique way, or found a pretty unique way to put the position or to make the offsets for each of these widgets and to animate them with really minimal effort and to make them slidable. So as you can see, this entire widget is wrapped in a single child scroll view, and as they're animating, it is still relevant to their relative offset. So for example, even if we are not viewing the bottom over here, it will still do the animation properly. As you can see, it's going off screen, although it's not showing it. So yeah, I am quite proud of this, to be honest. I think it turned out pretty well, and I definitely learned something new about layouts, and I'm going to show you that now. Essentially how we can get this scroll view and still have the offset or the positions to be relative to that widget that's within the single child scroll view. So let me show you. If we go 3D code, we have our home page, which is just the page view slider. And then at the end, we have the bubble sort page, the last page. So let's jump into that. And then it's just a column. We have the title. And then we have this aspect ratio widget, which essentially says that the width and the height should be equal to an aspect ratio of 1. So whatever the width is, the height should be equal to that. This can be anything. We can make this a sized box, for example, and give it a fixed size of 100. But the aspect ratio works well for this use case. So I'm just going to leave it as that. And then we have the child widget, which is called sort visualizer. So this is the magic widget that I'm talking about right here. So if we jump into this, you can see that the first widget is a single child scroll view. So that means we have the sized box, and then the child of that is a single child scroll view. So this single child scroll view will only pertain to that fixed size box. And then within that, we have a consumer, and that consumer is of type bubble sort provider. And if you want more information on the bubble sort provider or the provider package that I'm using, definitely check out my previous video. I go into more detail regarding that. Also check out my Patreon page. I'm releasing a video that is covering the architecture of this app, along with how I use Provider to manage the states in this application. I'll also be going into more detail with regards to the animation, and you can also find additional animation videos that I'm releasing. So if you are interested in animation, then definitely check that out. In this video, I'm literally just going to be showing you a couple of neat things that I've learned in the process of making this, and also touch on the bubble sort algorithm. Going back to what I was saying, so we have the child scroll view widget, and then beneath that we have the consumer. So this is where we get our states, basically all of these nodes, the data, and what their current position is. And then we have a container, and we give it a fixed height, well, not a fixed height, we calculate the height. And now that I think about this, this technically doesn't need to be a container. It can be a sized box because we don't use any other properties of a container. And then let's jump into this getHeight method. So in the getHeight method, we are requiring a size and a number of widgets. And the size we are setting equal to the, well, not equal to, we are getting the size from the media query. So this will be the size of our phone or our device. And then for the number of widgets, we are passing in the length of this widget over here, or not widget, the length of all of these nodes. So essentially the number of nodes that we are sorting. So within the getHeight method, we are taking the size, and then we are getting the width on the size attribute. And then we are doing a truncating division on that. So meaning we just want the integer value. We do not want a double value. And we divide that with the block size. And the block size is a value that we pass in. So as you can see, we have a default value of 100. So if we actually jump back a couple of times, and in the sort visualizer, which is this entire widget, if we give it a block size of say 150, you will see it changes depending on the size of the block. So by block, I mean each individual node. So let's make the 75. And you can see it's kind of cool springy animation that we get just by default Flutter magic over there. Okay, cool. So we're going to set that back to 100. And then going back to what I was saying, now we are calculating the number of rows. So what this horizontal fit value is, it essentially tells you how many of these nodes we can fit horizontally. It takes the width and it divides it by the size that we specify for each of these blocks. So if the size is 100 and the width is 400, that means we can fit 4 of these blocks horizontally. And then we also want to calculate the number of rows that will be in our available size. So we are taking the number of widgets that we pass in, and we divide that by the horizontal fit. Meaning, for example, if there are 20 of these nodes and we can fit in 4 per row, that will require we need 5 rows. In this case, we can do the math and see it's 4 times 4 is 16, so there's 18 nodes, meaning we still need the 5 rows. And then to get the height is we take the number of rows that we need and we multiply that by the block size that we passed in. So there's 5 rows and we multiply that by 100, which is default, or whatever the block size is. And that will give us the value of this single child scroll view, or the child widget within the single child scroll view. So this widget that's within inside scrollable will be equal to this getHeight. And then within the size box, we give it a child of a stack. So within the stack, you will see that we are giving it a sort widget, and we are building a sort widget for each of the numbers that are retrieved from the provider. And these numbers are a custom class that I made. As you can see, it's a list of type sort model. And this sort model basically just gives us access to information on the current states of each of these nodes. So whether they are sorted or still need to be sorted, as an example. And then for each one of those, we are building a sort widget. And within this sort widget, a very important thing that we are doing is we are setting the key. And I will touch on that in a moment. So let's jump into the sort widget. You can see that we are passing in a number of attributes. We are setting this number, which is of type sort model. And then we're passing in the index, so the position that we currently are at, and then the widget size. So here we are just passing in the block size again. So the block size that we are getting over here. Let's go to sort widget. Okay, so in the sort widget, you can see that we are doing some asserts, and this is just some checks to make sure that the properties are not null and to make sure that the values are bigger than 0 or bigger than some set size. What we are actually concerned about for the purposes of this video is the getPosition method, and this is where a lot of the magic happens. And if we scroll down here, you can see that in the build method, we are creating an offset that is equal to the getPosition, and then we pass in the size of the media query, so the size of the screen. And then we are using this offset variable in the animated position. So this entire widget, or this entire sort widget, returns an animated position, and we are setting the left and top value to be equal to this offset variable that we have here. And that is essentially what defines the position for each one of these individual number widgets. So how do we determine the position for each one of these widgets? Well, in the getPosition, you can see we are calculating a horizontal fit, same as the previous time. We are taking the width of the screen, and then we do a truncating division on the widget size. So again, this horizontal fit will essentially tell us how many nodes we can fit horizontally. In this particular instance, we can fit 4. So I think it will be easier if we do some additional printing or some additional logging and do a quick run. I'm just going to let this run through and then I'll discuss after. Okay, we are back. I didn't want the sort to be active while I explained the code, as it might be distracting. But now you can see we have been logging all of these calls, and let's find the index 0. So we are index 0, and we can see horizontal fit of 4, a vertical index of 0, and a horizontal index of 0. So that is what we expect. We have index 0 over here, and then the vertical index is 0, and the horizontal index is also 0. So if we expect the code, then we can say 0 divided by 4 would be equal to 0. And 0 modulo 4 would also be equal to 0. So basically, when we have an index of 0, then it will be at position 0, 0. However, if we have an index of 1, you can see that the horizontal index is now equal to 1. And that is because if we have 1 modulo 4, then it means that there remains a 1. Because what a modulo does, it looks for a whole division. So for example, 4 mod 4 or 4 modulo 4 would be equal to 0. However, 5 modulo 4 would be equal to 1. Essentially, 4, if you take 5 minus 4, then 1 will remain. If we, for example, say 8 modulo 4, then it would also be 0. Because you are dividing 8 by 4 and nothing remains. It's a whole number. But if you take 9 divided by 4 or 9 modulo 4, then again 1 will remain. If you're not familiar with modulo, I suggest you read up on it. There are loads of material out there that will explain it better than I am. But let's go back. So if we have 1 modulo 4, we have 1, but 1 divided by 4 is still 0. Well, it's not really 0, it would be 0.25, but because this is a truncating division, we discard the 0, or we discard these 0.25. So let's do another example. Let's choose 34. So 34 is at position 0, 1, 2, 3, 4, 5, 6. So if we say 6 modulo 4, 2 remains, and 6 divided by 4 would be equal to 1, because we discard the 0.5. And if we look where this is positioned, you can see vertically it is at 0, 1, so 1, and horizontally it is at 0, 1, 2. So basically at position 1, 2. And once we have these vertical indexes and the horizontal indexes, all we do is we return an offset with these indexes divided by, oh sorry, not divided by, but multiplied by the widget size. And that will give us these positions. So as an example, if the widget size is equal to 100, this one will be 0, 0 times 100 will be 0, 0, and 1, 1 or 0, 1 times 100 will be at position 0 and 100. And then we are just returning these values and then using them in our positioned widget. And what the animated positioned widget does, it takes the old position value and it compares it to the new value that you pass in, and then it does an animation. The animated positioned widget is much like the animated container and the animated default text style that we discussed in the previous video. However, now it just animates the position. And then within the build, we are doing additional things. These are just for the animation to trigger certain animation value changes if the state of our number widget, our sort model number widget is, sorry, not widget, but class has changed. And if you want more information on that, please check the previous video. I do go into more detail over there. And then, yeah, we have the offsets, and then we are returning this animated position. And that is how we achieve the animation. The rest is basically handled by Flutter. But what is really dope about this is the fact that we are first specifying a widget over here, and then we are giving this a single child scroll view. And that single child scroll view, we are passing in a widget that's basically bigger than its parent. And along with that, we can animate the positions even though they're not currently visible on screen. And yeah, that is basically most of the UI stuff. I glanced over a lot, but the core principle was basically the fact that you can pass in a bigger widget to a single child scroll view and then do some pretty cool offsets or positioning based on the child within a single child scroll view widget, if that makes sense. I do suggest you go and get the source code from GitHub and play around with this. In this video, I'm not going to go into more detail regarding the background logic. Feel free to check out the GitHub page and look at the source code if you want, or also check out the previous video. There I go into more detail. But if you would like to have even more detail or more in-depth content, then please go check out my Patreon page. I'm releasing a video over there going in-depth, discussing the architecture and discussing the state management, and also talking about how we can optimize the state management solution to make sure that we're not unnecessarily repainting widgets when we shouldn't be. Currently, this application is not as optimized as it can be, and it is doing unnecessary repaints. And a large portion of that boils down to state management. And in addition to that, I'm also currently doing a lot of unnecessary work. And by work, I don't mean work on the phone or the emulator, I mean work as a developer. For example, in my pages, I'm currently rewriting a lot of the same code. For example, the linear page and the binary search page are essentially exactly the same, and there's no reason for that to be the case. We can abstract this more, and the same for the bubble sort. And if you look at the providers, if you go onto GitHub and get the source code, you will see that I have base classes for the search provider model, and I have a base class for the sort provider. And depending on the algorithm that I implement, I extend the base class and then just add features on that. But this can be abstracted even more. So yeah, if that is something you are interested in, please go check out Patreon and give the videos over there a watch. I'm also releasing a video series on Patreon going in depth on how to do animation. So basically start to finish everything you need to know. And in the process, we'll be building a couple of very cool apps that achieve custom animation. And I don't consider this to be custom animation that you see in this application. All I'm doing here is implicit animations, essentially just extending animations that are provided by the Flutter framework. And although they are great, they are not suited for every situation. So yeah, in those videos, we are going from the basics to the very advanced. And I am learning a ton making those videos. So I do hope to see you over there. So go give a look at patreon.com/funwithflutter. And if you're only interested in the algorithm, I think if you download the source code for this app and give a read through of exactly what I'm doing, that will also benefit you a lot, or just playing around with these visualizers. And if you want more in-depth content, I highly recommend algoexpert.io. And if you want a discount, you can use the promo code FUNWITH for a 15% discount. Thank you for giving me your attention and watching this video. I will see you in the next video. Cheers.